This is my intermediate algebra course. Today we're going to review certain topics that we covered in previous courses, and we're also going to expand on those topics. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now this is the list of things we're going to cover today. Like I said, most of this stuff is review, but we are going to be expanding on those things and covering various characteristics of the topics we covered in more detail, just so you don't get bored. So part of the purpose for this class is to just jumpstart you, because you've been on break probably for a while now after finishing geometry and beginning algebra, and you may need a refresher. But we're also, like I said, just so you don't get bored, we're also going to be covering a lot of new things that are very important. So let's go ahead and get started. We're going to begin with equations with no solutions or infinite solutions. Now, of course, we've solved equations that have one solution, and that's what we're going to do in these problems, just to review a little bit, because if you're coming from my geometry course, then you may have taken a break for a couple weeks or a month or so, and you really don't do a lot of algebra in geometry, so it may be quite some time before you've done basic algebra. So we're going to review some general algebra. It says here, determine if each of the following equations has one solution, no solution, or infinite solutions. So we're going to start by solving equations that have one solution. Again, this is just review. But then we're going to go on to equations that have no solution or infinite solutions, which is expanding on on this topic of basic equations with one variable. So let's solve this equation. We're going to use distribution first, the distributive rule. Negative 5 times 3x is negative 15x. Negative 5 times 1 is negative 5. And we have x minus 8 on this side. So all we did there was just use the distribution rule. So you don't have to do this, but I'm going to go ahead and rewrite. And I'm going to show you every step, just to kind of jumpstart your mind here if you've been on a break for a while, showing you every step of these algebraic equations. But you don't have to show these steps when you do these problems for homework. So I'm adding 15x to both sides, and these cancel out. That was the whole purpose of that. So now we end up with negative 5 is equal to 16x minus 8. And now we're going to rewrite again. Again, you don't have to rewrite. I'm just doing this so you can remember how to do these basic equations. And so we're going to add 8 to both sides, and we get 16x is equal to 3. And we're going to rewrite again and divide both sides by 16. And we end up with our final answer. X is equal to 3 over 16. And as you can see, this equation has one solution. So we say one solution. So I should probably mention, I want you to demonstrate algebraically also. And so again, this is just basic review, and you don't have to show all these steps. You just have to show, maybe one or two intermediate steps. And this is just review. So try number 2. And remember, you have to use that distribution rule first, but you don't have to show all these steps. So try number 2, and when you come back, we'll do it together. All right, we're back. So we have 3x plus 7 is equal to 2x minus 8. Subtract 2x from both sides. Subtract 7 from both sides, and we get negative 15. And we can see that, again, there is one solution. So if you wrote one solution and you showed this work here, you demonstrated algebraically, good job. So now we're going on to problems where there's going to be no solution. So let's go to this equation and see what happens here. So we're going to first combine these x's over here. Remember, before you add or subtract something from both sides, or multiply or divide both sides, you want to simplify the expression. So x plus x is 2x. And now something very strange is going to happen, something that hasn't happened so far in my courses. I'm going to try to get the 2x on this side. So I'm going to subtract 2x from both sides. But when I do that, notice that something weird happens. The x's just cancel out. They disappear. And so we're left with 3 is equal to 8. And obviously 3 cannot be equal to 8. So what this tells us is that there is no solution. And what that means is that if you plug in any x value, it doesn't matter what x value you plug in, it's not going to make it work. For example, if you plugged in 0, then both these terms would go to 0, and you'd be left with 3 equals 8. If you plugged in 1, then you'd have 2 plus 3 is 5, and 2 plus 8 is 10, so you'd have 5 is equal to 10. And it just doesn't matter what x value you plug in. Because these two expressions are the same, and these two expressions or these two numbers are not the same, it doesn't matter what x value you plug in, it's not going to work in the equation, so therefore there's no solution. So in other words, when the x's cancel out and you're left with an equation that is not true, that tells you that there's no solution. So why don't you try number 4, and when you come back, we'll do it together. All right, we're back. So we get negative 7x is equal to 10 minus 7x. And you can see that, if I try to get this x on the other side, if I add 7x to both sides, then I end up with 0 is equal to 10, and that is not correct. So we have no solution. Again, when the x's cancel out and you're left with an equation that is not true, that means the equation has no solution. Now let's go on to the third situation when you have infinite solutions. So notice this equation is getting a little bit more complicated. Again, we're just using this as an opportunity to review, the basic algebra, but also expand on certain topics. We want to review, but I don't want this to be boring for you because you've already done all this stuff. So I want you to review and at the same time learn new things. So again, we've already learned equations with one solution. Now we're learning equations with no solution, which is what we just did. And now in this equation, we're learning equations with infinite solutions. So we use the distribution rule. Then we add the x's together on this side, and we end up with 4x plus 9. Add these together, we get 9. Remember, you can add like terms. And negative 12x plus 16x is 4x. But again, you have this situation where there's the same number of x's on each side. If I try to get this x on this side, or whatever, get this x on this side, it doesn't matter. The x's just cancel out, and I'm left with 9 is equal to 9. Now the difference with this situation is that the leftover equation is actually true. So in this situation, you have infinite solutions. When the x's are the same on both sides and they cancel out, you have infinite solutions. So what that means is it doesn't matter what x is. The equation is always going to work. Let's say I plug in 1 to both sides. Then I get 13 is equal to 13. If I plug in 0 to x for both sides, then I get 9 is equal to 9. If I plug in 2 to both sides, then I get 17 is equal to 17. And it doesn't matter what x is. It can be anything, and the equation is going to be true. So that's a situation where you have infinite solutions. So why don't you try number 6? And number 6 is going to be a little bit different, but it's the same situation where you have infinite solutions. So go ahead and try number 6, and when you come back, we'll do it together. All right, we're back. So we're going to use distribution to get rid of those parentheses. Whenever you have an equation with parentheses, you just use distribution to get rid of those parentheses first. Then we're going to add all the irregular numbers, and it looks like they all cancel out, and you're just left with negative 8x is equal to negative 8x. 3x minus 11x is negative 8x, and then if you try to get all the x's on one side, you add 8x to both sides, and you end up with 0 is equal to 0. But this equation is true. So that means the answer is infinite solutions. Again, the x's canceled out, and the remaining equation is true, which means it doesn't matter what x is, it's always going to make the equation true. So if you got that answer, good job. Remember, you have to explain algebraically how you know that there's infinite solutions or no solutions or one solution. So let's do a couple more of these problems. Why don't you try number 7, and you want to figure out if there's one solution, infinite solutions, or no solutions. So try number 7, and when you come back, we'll do it together. All right, we're back. So we're going to use distribution to get rid of the parentheses. And then we are going to subtract 3x from both sides, and we get 9x, and add 6 to both sides, and we get 12. And then we get 12 over 9, which reduces to 4 over 3. And so we have one solution. So if you said one solution, good job. But remember, you have to show all this work in order to demonstrate that there is one solution. So why don't you try number 8, and when you come back, we'll do it together. All right, we're back. So we're going to combine the x's. 5x minus 2x is 3x. And we're going to add 1 and 3 to get 4. And we're going to add 2x and 1x to get 3x. And then we're left with the following expression. And we're going to subtract 3x from both sides, and we're left with 4 is equal to 4. But so the x's cancel out, and we're left with an equation that is true, so that means there are infinite solutions. So if you wrote infinite solutions, good job. But remember, you have to demonstrate algebraically also. Okay, let's go on to the next problems here. Try number 9, and when you come back, we'll do it together. All right, we're back. Use the distribution property to get rid of those parentheses. And now we're going to 2 minus 20 is negative 18. So we want to simplify everything that we can before we start subtracting or adding to both sides. And you can see we have negative 20x on both sides. So we're going to add, I'm going to try to get this 20 over on this side. So add 20x to both sides. And we end up with 3 is equal to negative 18 because the x's just cancel out. So, but the resulting equation is not true. So that means that there's no solution. So if you got that answer and you showed algebraically why that was true, good job. Okay, so now we're going to go to systems of equations with no solutions or infinite solutions. So these were just basic equations with one variable, one variable equations. But you can also have systems of equations with no solution or infinite solutions. Now, remember, there's 3 methods for solving a system of equations, and we're going to show, in the same way we showed algebraically that there's one solution, no solution, or infinite solutions in the previous problems, we're going to show algebraically that there's no solution, infinite solutions, or one solution in these systems. But we're going to need to use our methods for solving a system of equation that we learned in previous classes. And so that's these methods here. Remember, we learned 3 methods for solving a system of equations, so we're going to do substitution first. Now remember, substitution and elimination are the methods that are actually used in the real world. Graphing is really not practical, and it takes too long, and it's not reliable, and it's just not, it's more of a conceptual thing rather than a practical method that we would use. So we're going to focus on these mostly, but we are going to review the graphing method. So now let's try using substitution first. Now, in case you forgot, it may be quite a while since we went over this, so if you don't remember this, that's okay. But notice we have a system of equations. There's 2 equations and there's 2 variables, so this is asking us to find x and y. We're not just finding x, we're finding x and we're finding y. So with the substitution method, first of all, how do we know to use the substitution method? Well, we can use any one of these methods. And, you know, it doesn't matter which one we use, but if you want to use the easiest method, you have to know, you know, what situation calls for which method. So if you recall, you use the substitution method when one of the letters is by itself on one side of the equation. In other words, in this equation, x is isolated right here by itself. So that means we're going to use substitution. So what we're going to do is we're going to take the equation where a variable is not isolated, the other equation, and we're going to rewrite it. We're going to write the same exact equation, no difference whatsoever, except instead of writing x, we're going to write what the first equation tells us x equals right here. So in other words, this here, I plugged it in there. And so, well, how did that help us? Well, it helped us because now we have an equation with one variable, and we can find y. And, you know, we're just simplifying, and we get y is equal to -1/2. So that is one of our answers. So now we use the other equation, the first equation, and we can find x. So x is equal to y, which we know we just found is -1/2, plus 2. And therefore x is equal to, we can say 1.5 or 3/2, however you want to write that. And that is the next equation, or that's the next solution. So this is, you know, we're just doing basic review right now. We're not talking about systems with no solution or infinite solutions. We're just talking about equations with one solution. This is stuff that you've done in previous classes, previous courses. Okay, so why don't you try number 11. We're going to use the substitution method again, and when you come back, we'll do it together. All right, we're back. So we're going to take the equation where, see, we have y is solved for here, so we're going to take the other equation where y is not solved for, and we're going to rewrite that, except instead of y, we're going to write what the second equation tells us y equals. So again, I took this here, and I plugged it in there. So now we have x minus 8x is equal to 42. -2 times 4x is -8x. And again, if you had some trouble with that, you know, it's okay. It's been a while since we did this, so don't be too hard on yourself. But, you know, you should have taken my beginning algebra course and my geometry course. If you didn't do that and you're in this class, you're in the wrong place. You got to go back and finish those courses. Now we're going to divide both sides by -7, and we get -6. So x is equal to -6. So now we're going to take the equation where y is solved for, and we're going to write 4 times the x value, which we just found, is equal to y. Therefore, y is equal to -24. So if you got that answer, good job. Again, that was the substitution method. And we can check our answers if we want to. Plug in -6, or plug in -24 here, and we get -24 times -2 is +48. And then add that to 6, and we get 42. So we can see that worked. And then plug in -6 here. -6 times 4 is -24. So you can check your answer that way. Okay, let's go on to number 12 here. Let's do this one together. So again, we're going to use the substitution method because one of the equations, a variable is solved for, x is solved for here. So we're going to take the other equation where x is not solved for, and we're going to rewrite that equation. Except instead of writing x, we're going to plug in what the first equation tells us x equals. So again, I took this here. I took this and plugged it in. So now we have 3y minus 8y plus 4 is equal to 5, getting rid of the parentheses there. 3y minus 8y is -5y. And solving that, we get y is equal to -1/5. You can skip some steps here. You don't have to show every single algebraic step. So now we're going to take the first equation, because that's just the easiest one to use, and we're going to write x is equal to 2 times, and we're going to plug in what we just found y equals. And doing the math on that, we get, looks like it's -7/5. You can write it as a mixed number if you want, -1 and 2/5 if you want. It doesn't really matter. So those are our two answers to that. And again, these are systems of equations which have one solution. You might say, wait a second, don't they have two solutions? There's one here and one here. Well, no, they're considered a pair, and it's one solution. Now we're going to go to the elimination method. So this is going to be really easy on this particular problem. We use elimination when one of the variables is not solved for, and all the variables are kind of on one side and lined up properly here. That's when we use elimination. And so notice that there's a 4y and a -4y. So we can just add those together immediately, and these are going to cancel out, and that's what we want. That's what we like. And we're going to end up with 8x over here, and we're going to end up with -8 here. And then we're going to divide both sides by 8, and we get x is equal to -1. And if you want, you can put this over here so it looks a little better, but maybe we should just keep it lined up there. All right, and so x is equal to -1, and then we can just plug in x to one of those equations. It doesn't really matter which one. I'm going to take the bottom one, 3 times x, and we found x is -1. And then we have -3 minus 4y is equal to -11. And we don't have a lot of room here, so I'm not going to show every step of this, but we end up with y is equal to 2. And that is the second solution, or not the second solution, but the second value. That's the value of y. So you can plug in to make sure that those work. And it looks like they both work. So that's an example where we would use elimination. Now there's something that I didn't talk about in my beginning algebra course, and that is you don't always have to have opposite signs in order to get rid of those. Notice that we added these two equations together. Here we don't have opposite signs. Now in my beginning algebra course I taught you if you don't have opposite signs you got to multiply both sides by a negative. But I didn't mention that you can also just subtract these two. So if we subtract this equation from this equation, that gets rid of the 7x's too. And as long as you get rid of those, that's all that we really care about. So now we have to do 2y minus -3y. Now this is a source of confusion for students. This is a double negative. It's going to be 5y, so be very careful about that. 2y minus -3y. Okay, 2y minus negative 3y. That's a double negative, which becomes a positive, and we get 5y. If you forgot that from my beginning algebra course or my pre-algebra course, well, now you know. We're reviewing. That's part of the purpose of this this class, is not only to review but to expand on topics. So now we know what y is, and we can just use one of these equations. It doesn't matter which one. I'm going to use the top one to find x. So we have 7x plus 2 times y, and we found y is 3. And then we have 7x plus 6 is equal to 20, and we can do the last two steps in our head. So we get x is equal to 2. So these are all examples of systems of equations that have one solution, and that solution is that pair of values. So now I want you to try number 15. You're going to use elimination, and when you come back, we'll do it together. All right, we're back. So notice that we have opposite signs and the same value there, so we're going to add these together. We get 17x is equal to 51. Again, these canceled out. So then we're going to divide both sides by 17, and we get 3. So if you got 3 for x, good job. Whoops, I forgot to put brackets on there. Then we're going to take one of those equations. I'll just take the bottom one and use that to find y. So 7 times x, which we just found is 3, plus 8y is equal to 21. And then we have 21 plus 8y is equal to 21. Subtract 21 from both sides, and we get 8y is equal to 0. Divide both sides by 8, and we get y is equal to 0. So x equals 3 and y equals 0. So if you got that answer, good job. Now, number 16 is a problem where, remember, like I said, you can use subtraction. See, we had different signs here, so you could just add them together and they would cancel out. But here you can't just add them together. They're not going to cancel out. Now, again, we could multiply one of these equations by -1, and that would change the sign. Then you could add them together. Adding a negative is the same thing as subtracting a positive. I know that's difficult to understand, but that's one way to do it. But another way to do it, so you don't have to you don't have to multiply both sides of the equation by -1, is you can just subtract this equation from this equation. So why don't you try that, and when you come back, we'll do it together. All right, we're back. So we're going to subtract this equation, and these just cancel out. Why do they cancel out? Because you have -3x minus -3x. Remember, a double negative, this is a double negative, that becomes a positive. And you just get 0, and that's what we want. So over here we have -y minus 2y, which is -3y. And some students have, they have trouble with this. So if you made a mistake there, that's okay, but just figure out what you did wrong. And here we have another double negative. -4 minus -1. That's -4 plus 1. So that would be -3. And so now we have y is equal to 1. And we can just use one of these equations, doesn't really matter which one, to find x. -3x minus 1 is equal to -4. I plugged in 1 for y. And doing this stuff, we end up with x is equal to 1. So if you got those solutions, good job. Again, that subtraction method is just something that I didn't go over in my course, but now I want to show you that. It's just another way to solve a system by elimination. Okay, so now we're going to do some more elimination problems. Again, we're reviewing systems of equations here, but now we can't just add these together or subtract them. It doesn't work. And the reason it doesn't work is because, notice, we don't have the same coefficients on these variables. So what we're going to have to do is we're going to have to multiply one of these equations, the top equation, we're going to have to multiply it by 4. So I'm going to go ahead and bring down this system, and I'm going to multiply both sides of the top equation by 4. And I'm just going to rewrite the second equation. When you're writing systems of equations, you know, the two equations, they have to go together. It's best to keep them together if you can. And so now we end up with, we have to use distribution here. So we get negative 8x plus 12y is equal to negative 4. And we're just going to, again, rewrite the bottom equation. Now, I know students are going to say, I don't want to rewrite the bottom equation. You know, how come I had to write it again? The equations have to go together. Sometimes in algebra, you have to rewrite stuff, and you're just going to have to get used to it. If you don't rewrite, then it's going to get really confusing. So now, at this point, you know, the big question is, well, why did we do that? I mean, what did that do for us? Well, we have coefficients that are now the same, and they just happen to be the opposite. So now we can add them together, and we get 7y is equal to 7, and y is equal to 1. Now we can take one of those equations. Doesn't really matter which one. I'm going to use the top equation up here to find x. So we have negative 2x plus 3 times y is equal to negative 1. And doing the algebra on that, we get negative 2x plus 3 is equal to negative 1. And it looks like we get x is equal to 2, but I'm just going to do that in my head because we don't have much room. X is equal to positive 2. All right, so that was just another example of elimination, but you had to multiply one of the equations in order to make them cancel out when you add or subtract them. So try number 18, and when you come back, we'll do it together. All right, we're back. So we're going to multiply the top equation by 2, and we're just going to rewrite the bottom equation because, again, they have to go together, or else it's going to get really confusing. And we end up with 8x plus 10y is equal to 18. And again, I know you don't want to do it, but you got to rewrite the bottom equation. They have to go together. And so now we're going to we don't have opposite signs. Now I could have multiplied both sides by negative 2, and then you would get opposite signs. That's another way to do it. So if you did it that way, that's fine. There's nothing wrong with that. But I'm just gonna subtract these two equations. You'll end up with 5x is equal to 5. And if you did it the other way, then you would get negative 5x is equal to negative 5. But you're still going to add up. You're still going to get the same answer, which is x is equal to 1. So if you got 1 for x, good job. Now I'm going to use the top equation. It doesn't matter which one we use. But I'm going to use the top equation to find y. So 4 times 1 plus 5y is equal to 9. And y is equal to 1. So if you got those solutions, good job. Okay, so now we're going to a situation where you're going to have to multiply both equations by a number in order to use elimination. So I'm going to multiply the top equation by 2, and I'm going to multiply the bottom equation by 3. And let's see what we get here. So negative 12x plus 10y is equal to negative 50. And 12x plus 21y is equal to 81. And so why did I do that? Well, you can see why we did that. Now we just add them together, and we get 31y is equal to 31. So y must be equal to 1. Now I'm going to use the bottom equation to find x. 4x plus 7 times y is equal to 27, and we get x is equal to 5. So that was a situation where you had to multiply both equations by a number, and I want you to try one of those problems. Again, this is all review. It's okay if you're rusty on this. It's not okay if you've never seen this. If you've never seen this, that's a problem. That means you need to go back and take one of my previous courses, both beginning algebra and possibly geometry also. But if you're struggling with the algebra, beginning algebra is really the thing that you need to, the course you need to take. But, all right, so try number 20. And when you're doing number 20, you know, if you can use a subtraction, if you can subtract, that would be a good thing to do, because that'll give you practice with the subtraction way of doing things rather than multiplying by a negative. So why don't you try number 20. Now, be aware that you can eliminate x or y. In this problem, I chose to eliminate x. See down here, I eliminated x. So in this problem, I'm going to eliminate y because I want to use the smallest numbers if I can. You can do it any way you want, but if you want to follow along with me, you're going to need to eliminate y. So go ahead and try number 20. Do it yourself. Don't wait for me to do it. You know, see if you can solve the problem, and when you come back, we'll do it together. All right, we're back. So I'm going to multiply the top equation by 3, and I'm going to multiply the bottom equation by 5, and we'll see where that gets us. So we have 18x plus 15y is equal to negative 18, and we have 25x plus 15y is equal to negative 25. And now we can use a subtraction property. We cannot add these together because I didn't multiply by a negative up here. So we can subtract, and then we get negative 7x is equal to 7. And we have x is equal to negative 1. So now we can use whatever equation we want to use to find y. So we have 5 times the x value, which we just found, plus 3y is equal to negative 5. And we have y is equal to 0. So let's check that just to be sure. Yep, that works. I just plugged them into my head real quickly here. That's the way you can check. So if you got that answer, good job. Okay, so that was review on substitution and elimination. Those are the ways to solve systems of equations. And we're also going to review the method on graphing. Now I'm going to go through this pretty quickly here, because this is really not what this class is about. I mean, we are using this as an example, or as an opportunity to review things. But remember, there's also the graphing method for solving a system of equations. And how that works is you graph one equation, and you graph another equation, and you figure out where they cross. That's the solution. That x and y value is the solution to the system. So that's what we're going to do here. But we have to review the whole concept of graphing. Remember, a big part of my beginning algebra course was learning how to graph linear equations. You have standard form, you have slope-intercept form, and you have point-slope form. And this form really doesn't help us much when it comes to graphing. We want to use x and y intercepts whenever we have this form. That's generally the easiest way to graph. We want to use, in this form, we want to use the slope and the intercept. That's why it's called the slope-intercept form. And in this form, we want to use a point, a random point, and well, not a random point, but a point you can see in the form, and the slope. You know, the names of these forms kind of give us indications on how we're going to use them to graph lines. So we're going to first solve this system here, and this first equation is in standard form. So what does that mean? Well, it means, you know, we're just going to have to use x and y intercepts. Now remember, you can convert. I mean, the table method works for any equation. It doesn't matter what form it's in. You can always use the table method where you choose an x value, say you choose 5, and then you figure out what the y value is going to be by using the equation. You can do that, but we'd prefer to stay away from that. I mean, technically we're going to do that when it comes to this method here, because what we're going to do is we're going to plug in 0 and then solve for y, whatever that may be, and then we're going to plug in 0 for y and solve for x, whatever that may be. So that's just the easiest way to graph this particular equation. We're not going to go over this in detail right now because that's not the point of this class. The point of this class is just to see how to solve a system of equations. So using the graphing method. So now we're going to let x equal 0, and if x equals 0, we can see that y is equal to negative 6. So now we're going to plot that, and we plot that down here. And now we need one more point, so now we're going to let y equal 0 and solve for x. And we see that if y is 0, then x is equal to 2. So that would be right here. So now we're going to connect the dots. And this is not an art class. Your line doesn't have to be perfect, but it does have to be relatively straight. Also, you want to fill your window. A lot of students, they start here and go to there, and then they just stop. That's not enough. You got to fill up the entire window. Okay, so now we're going to go to the next graph. Now, thankfully, this next graph is in slope-intercept form. So what that means is it's going to be really easy to graph. You look at the intercept, that's at 6, so that's up here. And you look at the slope. Now, it may be a little hard to see the slope, but the slope is the coefficient of x, so the slope is actually negative 1. So what that means is you go down 1 and over 1, plot that point, and you can do it again, down 1 and over 1, and plot that point. Or if you want to, you can go down like 1, 2, 3, 4, and then 1, 2, 3, 4 if you want to save time. So then you connect those dots, and you can see that our solution is going to be somewhere around here. Now remember that I mentioned that this method is really not very reliable, and you can see the solution to this system, just so you know, the solution to this system is actually 3, 3. The x value is 3 and the y value is 3. That's right here. But our lines didn't cross right there. How come? Well, because my lines weren't perfectly straight. And it may be that this graphing paper is not perfect. This is just not a reliable method. I can try to get a little better there. That's maybe a little better. As you can see, my line was not quite right. So this is not a very reliable method, but you can see it was supposed to be around 3. 3, 3. So the solution is x is equal to 3 and y is equal to 3. So again, we don't really use the graphing method very much to solve systems of equations, but you need to know the general concept that where the lines cross, that's the solution. Okay, so let's try one more of these, and this is not only helping you with the concept of solving a system by graphing, but it's also helping you to review graphing linear equations. It's very important. This is kind of jump-starting your mind. So now we have this standard form again. So we're going to use x and y intercepts. We're going to let x equal, let's let y equal 0. If y equals 0, then this goes to 0, and we solve for x, and we get negative 2. So that's an x-intercept. And if we let x equal 0, then y is going to be equal to negative 10 thirds, which is negative 3 1/3. So that would be about down here, right here. And now we can just connect the dots. And if you can, you want to avoid going too far. You don't want to go outside the window. All right, so now let's graph again. This form is not really very useful for graphing. It's a little harder to deal with that. But this form down here, if you notice, that's in point-slope form. We haven't seen that one yet. We saw slope-intercept form, but we haven't seen point-slope form. So with point-slope form, you just use the point, and the point is negative 1, positive 2. Now, you might be thinking, wait a second, that's positive 1, negative 2. What are you talking about? Why did you change the signs? Well, remember, you have to change the signs. That's just how the algorithm works. The point is -1, 2. So I'm going to go ahead and plot that point, and it's about right here. And then we're going to use the slope, which is here. And again, you might be thinking, how did you know that was the slope? Well, it's just this, we're just looking at this form. This tells us what the slope is. That's the usefulness of this form, is you can just see the slope by looking at it. Now again, you need to know that this is actually flipped over. So the y's are on the right side here, and they're on the left side here. Remember, the symmetric property of equality tells you can flip an equation. It doesn't make any difference. So now we use the slope. The slope is 2, but remember, any whole number can be written as 2 over 1. So the rise is 2 and the run is 1. Remember, it's rise over run. So we're going to go up 2 and over 1. So up 2 over 1 and plot that. And just to make the line straighter, we can go up again. Up 2 over 1. And then we can go down 2 and to the left 1. Down 2 to the left 1, down 2 to the left 1, just to make sure our line is nice and straight. And you can see that this time it's fairly obvious what the answer is. But again, this is not a reliable method. So x is equal to -2 and y is equal to 0. So again, we're reviewing how to graph linear equations, and we're reviewing how to solve a system by graphing. We don't know if it lands exactly at this point. The only way we could confirm that that's the solution is by actually using substitution or elimination. That's another reason that graphing is kind of a ridiculous way to solve a system. Okay, so now it's time for you to try. I'm going to leave those in the window. I'm going to leave all that stuff in the window. I want you to try number 23. And you're going to use point-slope form. And this is slope-intercept form. Now remember, when you have slope-intercept form, you can see the intercept. This is the y-intercept, where the line crosses the y-axis, and you're going to use the slope. So plot this point, which is 0, 1, and then use the slope to graph that line. So try number 23, and when you come back, we'll do it together. All right, we're back. So the y-intercept for the red line is 1, and the slope is up 2 and over 3. So up 2 and over 3, up 2 and over 3. Now we can go down 2 and to the left 3, down 2 to the left 3, down 2 to the left 3. That just helps us graph the line better. That line didn't look very straight. Yep. I didn't go out far enough. There we go. All right, so now we're going to use point-slope form with the green equation, and the point is -5 and -6. Again, it's opposite signs. And that's going to be down here, and then we're going to use the slope, which is -3. Again, that's the same thing as -3 over 1. So the rise is -3 and the run is 1. But notice we've come across a problem here because we can't go down 3 and over 1 because that goes out of the page. So what we have to do is we have to go up 3 and to the left 1. And there you see, we can then graph. We're going to have to extend this out a little bit. We can then graph that line. And we can see roughly where the intersection point is. So we have 1, 2, 3, 4, 5, 6, 1, 2, 3. So it looks like the x value is -6 and the y value is -3. So if you got those answers, good job. I'm sorry if I gave you kind of a twist problem there because we couldn't go down and over. We had to go up and to the left, but you should have seen that just by looking at these problems here. Obviously I was doing that. So if you got that answer, good job. Okay, so that was solving a system by graphing. So those are the three methods for solving systems of equations. And again, that was just review of systems of equations and also graphing, linear equations, so on and so forth. But now we're going to something new. This is something you haven't seen. This is where we figure out if a system has one solution, like the systems we solved previously, or if it has no solution or infinite solutions. So this is not going to be hard. It's basically the same thing. Now I'm starting out with a situation that you actually haven't seen yet. Remember, we use substitution because we have to figure out what method we're going to use. Are we going to use substitution, elimination, or we never use really graphing. So it's either substitution or elimination. So which one do we use? Well, we see that y is isolated in this equation. So obviously we're going to use substitution, but it's kind of confusing because y is isolated in this equation too. So what do? Well, we actually do the same exact thing we did before. There's no difference in this problem. What you're going to do is you're going to take either one of these equations. It doesn't really matter which one. You can take the top one and you're going to rewrite it. But instead of writing y, you're going to write what the second equation tells us y equals. So negative 5x plus 10 is equal to negative 5x plus 3. So again, all I did was just rewrite the top equation, no difference whatsoever, except instead of y, I wrote negative 5x plus 10, because that's what the second equation tells us that y equals. So now you can see what's going to happen here. We have two x's on both sides, and we're going to add 5x to both sides, and we end up with 10 is equal to 3. So that doesn't make any sense. So obviously we have no solution. So as you can see, the method for determining whether or not a system of equations has no solution or infinite solutions is pretty much the same method that we used when we have just one equation. So let's try another one of these. Here we have an equation where elimination would be the best method to use. So we're going to go ahead and subtract those. We're going to subtract the bottom equation from the top equation. And we get here, these cancel out, but they cancel out here also. So we end up with 0. And 4 minus 1 is 3, so we get 0 equals 3. So we can see that there's no solution. Another problem where we have no solution. All right, so that's what it looks like when a system of equations has no solution. So number 26, it looks like you're going to use substitution because you have an equation where a variable is isolated. But be aware, you have a second equation where a variable is also isolated. So the big question is, what equation do you use? Well, you can use either one. It doesn't matter. Don't get confused by that. Just use either one. So I'm going to use the first equation. So if you want to follow along with me, you can do it that way. But try 26 on your own. Don't wait for me to do it. And when you come back, we'll do it together. You're going to use substitution in this equation, and you're going to find that there's no solution. So try 26, and when you come back, we'll do it together. All right, we're back. So I'm going to rewrite the first equation, but instead of x, I'm going to write what x equals, or what the second equation tells us that x equals. So I took this and plugged it in here. So now I'm just going to solve that equation, but when you solve that equation, 6 minus 4 is 2. And when you try to go further, if I try to put this y on the other side, they just cancel out. If I subtract y from both sides, they disappear, and I get 2 equals 0, and you can see pretty obviously that that's no solution. So if you got that answer, good job. Okay, so let's do the next problem together. This next problem, I believe, is going to have infinite solutions. So you're going to see what happens here. So we're going to use substitution because one of the variables is solved for. We're going to take the equation where the variable is not solved for, and we're going to rewrite it. But instead of plugging in y, we're going to plug in what the second equation tells us that y is equal to. And then we are going to have to use distribution. So 2 times negative 2x and 2 times 1/2. So then we get negative 4x plus 1 is equal to 1. And notice that these just cancel out. 4x minus 4x is 0, and we're left with 1 is equal to 1. The difference is that this leftover expression or equation is true, whereas the leftover equation over there was not true. So the answer here is, as you can imagine, infinite solutions. So there's really no difference from what we were doing before. It's pretty much the same procedures, but you can see that x is canceled out, and that means there's going to be no solution or infinite solutions. All right, let's try number 28. In fact, you try number 28 on your own, and you're going to see that there's infinite solutions. So go ahead and try 28, and you're going to have to multiply one of these equations. You're going to have to use elimination, and you shouldn't have to multiply both equations, though. So try 28. When you come back, we'll do it together. All right, we're back. So I'm going to multiply the top equation by 3, or you can multiply it by negative 3. It doesn't really matter. It just depends on how you want to do it. And then I know you don't want to do it, but we have to rewrite the bottom equation. And we get 9x plus 6y is equal to negative 15. And negative 9x minus 6y is equal to 15. And now we're going to, we can add these together because we know they're going to cancel out if we add them together. The x's cancel out, but something strange happens. The y's cancel out also. So you're left with 0 over here, and these cancel out also, so you're left with 0. So if you have 0 equals 0, that means, as you can imagine, infinite solutions. So if you got that answer, good job. And if you use the algebra to prove your answer, good job. You need to prove your answer with the algebra. Okay, so those were systems of equations with infinite solutions. Now we're going to go to the graphical representation of those. So now these are some systems that we went over, and we found that this system here had no solution. Now, if you graph a system that has no solution, what ends up happening is the lines are parallel. Remember, if a system has a solution, that means the lines are going to cross, as you see down here, and the point where they cross, the point of intersection, that's the solution to the system. But if a system doesn't have a solution, obviously they can't cross. So again, if the system has no solution, then they don't touch. They're just parallel. Now, if a system has infinite solutions, what that means is that these equations are really just the same equation. They're just in different forms. And what that means is that if you graph them, they actually are right on top of each other. Okay? So it's very important to understand the graphical representations of these different situations. That's going to be useful in various problems in courses, later courses. And we're not going to do a lot with this. It's there's really not much we can do with this. You just need to know what these graphs look like if there's no solutions, infinite solutions, or one solution of a system of equations. Okay, now we're going to inequalities. So we didn't go over inequalities in my beginning algebra course, but we did go over inequalities quite a bit in my pre-algebra course, and we did a few inequalities in my geometry course. But in case you forgot what exactly equalities are, or inequalities, if you see this symbol here, that means that whatever this number is, it has to be greater than this number. And remember, you can remember that by using Pac-Man. Pac-Man wants to eat the bigger number. Over here, I'm going to write equal to. Over here, we have another example where Pac-Man wants to eat the bigger number. This number is bigger. Remember, if a number is negative, then the bigger it is, the smaller it is. You know, I know that's kind of weird to think about, but -2 is actually bigger than -4. Pac-Man wants to eat them. But the equal to sign, which really doesn't apply here, I should get rid of that. The equal to sign means that it can be something can be less than or equal to. And also, you want to remember, when you read these inequalities, it's very confusing. Very confusing for students because you want to read from left to right. This is a greater than symbol. The reason it's called a greater than symbol is because, you read left to right. 3 is greater than 2. This is a less than symbol because reading left to right, you say -4 is less than -2. But just be aware that I can flip this around. This statement here is the exact same statement. But now I'm reading left to right again. It's 2 is less than 3. Rather than 3 is greater than 2. It's the same it's the same situation. But if you do reverse this, if you say 2 is greater than 3, then obviously that's wrong. So just be aware of all this. So now we're going to find the algebraic solutions and the graphical solutions of the following inequalities, just to review here. And we're going to need this for some subsequent classes. So this is going to help us prepare for classes that we're going to do later on in this course. So we're just going to use distribution here and solve this inequality. You can just pretend that this is an equal sign and just solve it the same way you'd solve an equation. Now subtract x from both sides and subtract 4 from both sides and divide both sides by 3, and we get x is, well, remember, we have to read left to right, so -2/3 is greater than x. That is the algebraic solution. But we also have to do the graphical solution. So using the graphical solution, we need to use an open circle because it's not greater than or equal to, it's just greater than. And we write -2/3, and x can be anything that is less than -2/3, so we color in this part. So x can be anything less than -2/3, but it can't be equal to -2/3. That's what this solution means. So we've got the graphical and algebraic solution. So for number 30, be aware that you're going to have to use a closed dot instead of an open dot because this is less than or equal to. So go ahead and try number 30, and when you come back, we'll do it together. All right, we're back. So subtract 2 from both sides, divide both sides by 5, and we have x is less than or equal to 2/5. So that is the algebraic solution of that inequality. Now we're going to graph it, and we need a closed dot, and that point there on the number line is 2/5, and it tells us that x is less than or equal to, so again it's on the left side. That's just a coincidence that it ended up being on the left side again. Sometimes it's on the right side. So if you got those answers, good job. Okay, so now for number 31, let's do this one together. Remember, sometimes you have to flip the inequality. So we're going to add 3 or subtract 3 from both sides, and we get -7 is greater than or equal to -x. So now this is the same thing. Just to remind you, students have a lot of problems with this. This is the same thing as saying -1 times x. Again, when you just have a negative there, that you don't. If it's just -1 as the coefficient, you don't have to write the 1. It's just kind of a waste of effort to write the 1. Okay, so now we're going to divide both sides by -1, but whenever you divide or multiply an inequality by a negative, both sides of an inequality, you have to flip the inequality. That's a very, very important point. A lot of students forget that. So that is the algebraic solution. And again, notice we flipped the inequality because we divided by a negative. Now we're going to graph it. And now x is bigger. We need a closed dot because it's less than or equal to. And x is bigger, so we shade in this part over here. Now for number 32, you're going to multiply by a negative. In this problem, you had to divide both sides of the inequality by a negative. Here you're going to have to multiply both sides of the inequality by a negative. But because you're multiplying by a negative, you have to flip that inequality. So try number 32. When you come back, we'll do it together. All right, we're back. Subtract 4 from both sides. Multiply both sides by -3. Well, actually, I'm going to do this by steps just so you can see what's going on here. So you don't flip the inequality yet. But now when you multiply both sides by -3, now you have to flip that inequality. So that is the algebraic solution. So as less than, that changes to greater than, and we have the inequality. And we need an open circle, and x is less than -6. So that goes over here. So if you got those answers, good job. Okay, on to the next problem. So now we're going to graph linear inequalities. This is review from my pre-algebra course. So this is slope-intercept form. So I'm going to graph the y-intercept. That's going to be here. And I'm going to use the slope. We're going to go up 3 and over 4. So 1, 2, 3, and then 1, 2, 3, 4. I know it's kind of confusing because you know, each tick mark here is two coordinates. So be aware of that. So 1, 2, 3 going down, and then 1, 2, 3, 4. Just getting some more points here to make sure the line is straight. And there you go. So that's that graph. And what we're going to do is we're going to either shade this side or we're going to shade this side. Do you remember this from my pre-algebra course? But we have to do a test point to figure out which side works. So probably the easiest point to choose is 0, 0. And so now we're going to plug in 0, 0 to this inequality and see if it works. So 0 is greater than or equal to 3/4 times 0 plus 2. So I just plugged in 0 for x and 0 for y because that's the point we're using, 0, 0. So now we have 0 is greater than or equal to 0 times 3/4 is 0. And then we simplify and we get 0 is greater than or equal to 2. And the big question is this true? And the obvious answer is no, this is not true. So let me get a big old red mark there, and we can do like a cross and say no, it's not true. So therefore, we're not going to shade in this side. Instead, we're going to shade in this side over here. And so that means that all points on this side of the line, they work in this inequality if you plug them in. But it's also important to understand that the points on the line, they work also. So just be aware of that. Okay, so on to number 34. Let's try another one of these. Now this is in standard form. So the best way to graph this is by using x and y intercept. So I'm going to let y equal 0. That makes this go to 0, and x must be equal to -1 if you solve for that. So -1, 0. And that would be about here. And then I'm going to let x equals 0, solve for y, then we get a fraction, which is kind of inconvenient, but you know, that's just the downsides of having you know, standard form. So we get 0 and -2/3. So 0 and negative 2/3 is going to be about here. And now it's very important to understand that we have it's not less than or equal to, it's just less than, so we have to use a dotted line. What that means is that the points on the line are not going to work in the inequality. Whereas with this problem up here, the points on the line, they actually worked. Okay, so now we need to figure out if we're going to shade this side or this side. This side. So we're going to do a test point. And it looks like we can use 0, 0 again. That's usually one of the easiest points to use. You can use any point you want as long as you're sure that it's away from that line. So let's plug it into the inequality. 2 times 0 plus 3 times 0 is less than negative 2. We're going to see if that works. So we get 0 plus 0 is less than negative 2. 0 plus 0 is just 0. So the big question is 0 less than negative 2? And the answer is obviously no. So that means that we're going to shade the other region over here. Because it doesn't work, the 0, 0 over here didn't work, so we have to shade down here. That means all the points below the line are going to work in that inequality. But just keep in mind that the actual dotted line, the points on the dotted line are not going to work. So why don't you go ahead and try number 35. And keep in mind, you're probably going to need graphing paper. Well, you don't need graphing paper, but it'd be helpful. And if you're going to use my scale here, each one of these tick marks is 2 units. Be aware of that. Don't be fooled by that. Also, this is point slope form, so you can see a point on the line just by looking at it, and you can also see the slope. And remember, your point is going to be the opposite sides of these. So go ahead and try number 35, and when you come back, we'll do it together. All right, we're back. So our point is going to be 4, 2. So 1, 2, 3, 4, 1, 2. Mark that point. Our slope is 2, which is the same thing as 2 over 1. So the rise is 2 and the run is 1. So going up 2 and over 1 puts us about there. Then we can go down 2 and over 1 just to find some more points here so we make sure our line is straight. Down 2 over 1, down 2 over 1, down 2 over 1, so on and so forth. You don't have to do all these points, but it just helps to make sure your line is straight. And so that is the line, and it has to be a full line because it's less than or equal to. So now we're going to do the test point, and usually 0, 0 is the easiest point to use, so we'll just go ahead and use that point again. You can use any point that's on this side of the line or this side of the line, as long as you're not choosing a point on the line. So we'll just choose 0, 0 because that makes it easy. So then we have 2 times 0 minus 4 is less than or equal to 0 minus 2, and we're going to see if this inequality is true. So now you might want to distribute here, but it's probably better if you just subtract 4 from 0 to get negative 4. I mean, there's no variables in here, so why distribute? Well, you can just do the operations inside. 0 minus 2 is negative 2, and we get negative 8 is less than or equal to negative 2. And so is that true? And the answer is yes, it is true. So that means we're going to shade the side that this point is on, which is this side over here. So we just shade all that in. And, it doesn't have to be perfect, just so that people know that it's this side of the line. So if you drew this graph, good job. Okay, let's go to the next problems. So now we're going to graphing systems of linear inequalities. Now this is something that we haven't done. This is new. You know, it's mostly based on the same principles, but it is something that's fairly new. Now, normally when we're using systems, we have systems of equations, but these are not systems of. This is not a system of equations. It's a system of inequalities. We haven't seen that yet. Now, when you're solving a system of inequalities, you can't really solve it algebraically because this is actually the solution. There's nothing you can really do much more than that. But you can graph a system of inequalities and show the solutions on a graph, so that's really the easiest way to demonstrate what the solutions are. So we're going to graph the first inequality, and it's in point-slope form there, if you consider that an equation. So we have 2, -4 is the point. So that's here, and we're going to use the slope, which is -5, 6. Now, notice I cannot go down 5 and over 6. So I have to go up 5, 1, 2, 3, 4, 5, and over to the left 6, 1, 2, 3, 4, 5, 6. And I can do that again, 1, 2, 3, 4, 5, 1. Actually, I can't do that. It goes off the page. But you can use fraction numbers if you want to keep the line straight there. And I just noticed that's greater than, but it's not equal to, so I got to make dots on that one. Okay, so now we're going to graph the green line. So that's in slope-intercept form. So the intercept is -1. And the slope, now it's kind of hard to see the slope. You can rewrite that as 1/3 times x, and you can see the slope is 1 over 3. So the rise is 1 and the run is 3. So we're going to go up 1 and over 3, up 1 and over 3. And if we want to make sure the line is straight, we can go down 1 and to the left 3, down 1 and to the left 3, so on and so forth. I think you get the point. And this is going to be a solid line. And so now, at this point, what we're going to do is we're going to shade in one of the resulting regions. Notice that we have 4 regions. We have this region, we have this region, and this region. One of those regions, and only one, is going to work. Only one of them is going to be the correct, is going to contain the points that make these inequalities true. The points on the graph have to make both of these inequalities true, not just one. So there's going to be some of these regions where a point will work in one equality, but it won't work in the other inequality. We have to find the region where the point works, all the points work in both inequalities. So we're going to try a test point, 0, -5. So we're going to test this region down here first. You might be wondering, why don't we test 0, 0? Well, I'm just trying something different here. So we're going to try in 0, -5. So let's try that in the first equation. So -5 is y. And 0 is x. So then we get -1 is greater than -5, 6 times 0 minus 2 is -2. And we don't really have to go all the way to the end because we can already see what's going to happen here. A negative times a negative is a positive. So we get 10, 6, and you can see that this is not true. So we're going to say, no, it's not that region. So now let's use another test. So basically what that shows is this region we're not going to shade in. It's not that region because we already proved that one of these doesn't work. That point doesn't work in the first inequality. Now if it did work in the first equality, we would then have to plug it into the second inequality and make sure it works in that one also. But we don't have to do that because we can already see, again, it doesn't work in the first inequality. So now let's test another point, 6, 0. And we're going to plug that into the same equation. 0 plus 4 is greater than -5, 6 times 6 minus 2. And we have 4 is greater than negative 5/6 times 4. And all we're trying to do is see if the inequality works. We don't necessarily have to go all the way to the end here. But, we might as well. So we get negative 20 over 6. And you can see that this is true. This actually does work. So what I'm going to do is I'm going to say, well, okay, this might be the correct region, so I'm going to move this over. And because that worked, we now have to check that point, 6, 0, in the other equation. So now we're going to plug in 6, 0 to the top equation, and we get 6 over 3 minus 1 is less than or equal to 0. And 6 over 3 is 2. And we get 1 is less than or equal to 0. So it did not work. Here it worked. Here it did not. So what that means is this region 6, 0, and by the way, the 6, 0 was, it was over here. We're testing this region for test point number 2. So we know that this is not the correct region. We know this is not the correct region. So now we have to test these two regions. So for test point 3, I'm going to choose 0, 0. So now I'm testing the top region there. So plug in 0, 0, and we get 0 plus 4 is greater than negative 5/6 times 0 minus 2. 4 is greater than negative 5/6 times negative 2. And we have 4 is greater than positive 10/6. And, if we simplify a little bit here, we can see if you change that to a mixed number, you get 1 2/3. And we can see that 4 is definitely greater than 1 2/3. So now what we're going to do is we're going to plug it into the other equation and see if it works in the other equation. And if it works in the other equation, then that's going to prove that that region is the proper region. So we just make some room here. So now we're going to plug in 0, 0 to the bottom equation there, the green one. So 0 over 3 minus 1 is less than or equal to 0. And we get negative 1 is less than or equal to 0. So we can see that it worked in both inequalities. So what that means is we need to shade in this region up here. And that's how you write the solutions for a system of inequalities. The best way to do it is to graph and show the shaded region where all the points work. So again, what that means is that if you plug in any point into these inequalities, those points are all going to work. That's what that means. So that's the graphical solution of a system of inequalities. So now let's try another one of these together. Now we have, you can try this one on your own if you want, or you can do this with me. But we're going to do one more after this, just to make sure you got it. So we're going to go a little bit faster here. So here we have standard form. We're going to let x equals 0 and y equals 5. And we're going to let y equals 0 and x equals 1. So how did I do that? Well, again, I'm just letting one variable be 0 and solving for the other variable. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Just using that pattern, I'm continuing there. And we need to use dotted lines because it's not less than or equal to, it's just less than. So now we're using the slope-intercept form. The intercept is 1, and the slope is the coefficient of x, which is just 1. So we're just going up and over 1, and so now we have a full line because it's greater than or equal to. And now we need to know what region we're going to shade in. Is it going to be this region, this region, this region, or this region? We don't know. We have to test points. So I'm going to test, I'm going to test 1, 2, 3, 4. I'm going to test 5, 0. All right, so 5 times 5 plus 0 is less than 5. And I should probably color that. And we get 25 is less than 5, and obviously that is not correct. So what that means is we don't have to test any other points there. We know that's not going to work. So now we can go to another test point for another region. So test point, and what should we try now? Let's see, how about 0, negative 2? All right, so 0, 5 times 0 minus 2 is less than 5. And, you know, you can do a lot of this in your head. You know, I'm just showing the work for you. You can see that that actually works. So now let's test that point. Now that that inequality works, we're going to need to test that point in the other inequality. So now we have negative 2 is greater than or equal to 0 plus 1. And we can see that that obviously doesn't work. So now we're going to have to do another test point here. So what we've proven is this area and this area, they're not the solutions. So now let's try negative 5, 0. That's this region over here. And we have 5 times negative 5 plus 0 is less than 5. And we get negative 25 is less than 5, so that works. So what that means is now we have to go to the other equation and test that. So now we have 0 is greater than or equal to negative 5 plus 1. And we end up with 0 is greater than or equal to negative 4, and that works. Whoops, I accidentally wrote no there. I meant to write yes. These both worked. So what that means is that region over there is the correct region that we need to shade in. Okay, so I want you to try one of these and notice that we have standard form, which means you're going to have to use x and y intercepts. Let x be 0, solve for y. Let y be 0, solve for x. And don't worry about now flipping inequalities, because that's not really what we're doing here. And here you have point slope form, so you're going to have to use point slope form. And if you don't remember all that stuff, you can take a screenshot of these forms of the equations and use those to help you with this problem. So go ahead and try number 38, and when you come back, we'll do it together. All right, we're back. So I'm going to plot the top inequality first. So we have negative 2 and 2. That's the point, and then we're going to use the slope, which is 4 over 1. So up 1, 2, 3, 4, up 1. And then we can go down 1, 2, 3, 4, and over 1. And again, 1, 2, 3, 4, and over 1, just to make sure our line is straight. And this is greater than or equal to, so we need dotted lines. So now the second equation, like I said, it's in standard form. So we're going to let y equals 0 and solve for x, and we get negative 2. So we get negative 2, 0. And then we're going to let x equals 0, solve for y, and we get negative 2 and 2/3. So 0 and negative 2 and 2/3, which is about here. And that's also a dotted line. And again, your lines don't have to be perfect. Okay, so now we need to figure out what area to shade in, so we'll do a test point. And I'm going to use 0, 0. And you know what, I'm just going to skip through here because we don't really have time to test every single area. 0, 0 is not going to work. Let's see here. It looks like this region is actually going to be the region. So let's test 0, negative 10. The reason I'm choosing negative 10 is I want to get way down here. I want to make sure I'm not on the actual lines. Sometimes students choose a point and it's too close to the line, and they accidentally they don't realize they actually accidentally that because the line is not perfectly straight, the point is actually on the other side. So that can be really annoying. All right, so plug in 0, negative 10, and we get 4 times 0 plus 2 is greater than negative 10 minus 2. And we get 4 times 2 is greater than negative 12, and we get 8 is greater than negative 12. That works. Plug in the same point to the other equation, or other inequality, actually. And we want to simplify that. And we get 0 plus 30 is greater than 8. 30 is greater than 8, and that works also. So that proves that this region down here is going to be, all those points work in the system of inequalities. It's got to work in both inequalities, not just one. So if you got that answer, good job. So again, we use this class as an opportunity to review a lot of important things that we're going to need for this course. And we also use that as an opportunity to expand on the things and learn, expand on the things that we've already learned and learn new things. So now let's take screenshots of all the work that we did today, in case you want to have help with your homework or use these to study for tests. That's screenshot number 1, screenshot number 2, screenshot number 3, screenshot number 4, screenshot number 5, screenshot number 6, screenshot number 7, and screenshot number 8. Now don't go before you get your homework. Let's take a look at the homework. So here's the homework. Now you want to get a screenshot of these 2 pages. Now if you don't know how to do a screenshot, just go on Google and type in your model of whatever device you're using and ask Google how to do a screenshot. And so this is screenshot number 1 and screenshot number 2. Now you can just go on this YouTube video or wherever this is shown, and in the comment section you can just push on a number and it'll take you straight to the homework also. But eventually you don't want to keep a YouTube video open on pause just to see the homework, so you probably want to get screenshots of these and put them in some sort of put them in a file in your computer or your phone or your tablet. And you want to name that file Intermediate Algebra, and you want to be able to access your homework and the notes or whatever you need instantly without really having to go on YouTube. And of course, there's also a link on the comment section where you can go straight to the notes if you want to take screenshots of the notes. And this is just the easiest way to get the homework. Now remember, your homework has to have these 4 characteristics. It has to be complete, correct, neat, and in correct chronological order in your binder. If one of these 4 characteristics doesn't fit your homework, then your homework is a complete waste of time. If you only do half of the homework, then you didn't do the homework. If a lot of your problems are wrong, then you didn't do the homework. If people can't even read your work, then you didn't do the homework. And if it's not in the correct chronological order, then you didn't do the homework. Because it doesn't matter if all these are, if you did all these, if you can't find your homework, it doesn't really matter. So again, your homework has to have all 4 of these characteristics, no excuses whatsoever. And if you don't do the homework, it's 100% guarantee that you're going to learn absolutely nothing in this entire course. You will not achieve the objective of the course. Now, regarding this particular assignment, if you just write the answers and you don't really show your work, then all that proves is that you're trying to make people believe that you did the work when you really didn't. And so you need to demonstrate algebraically. If you get 5 equals 0, which shows that there's no solution, you have to demonstrate how you got 5 equals 0. You have to demonstrate the algebra. If you got -3 equals -3, which shows that there's infinite solutions, you need to show the algebra that you did to get to that point. And if there's one solution, you have to show algebraically how you found that one solution. Now the solution itself is not part of the answer, as you can see, but you have to show how you got the answer, and the one solution tells you how you came to the conclusion that there's one solution. Also, it's very important that you organize your homework just like I have it organized. Okay, I want your name, the date, and the course title. The course title is Intermediate Algebra. You need to write a title up here, and you need to circle your problem numbers. Okay, now you may say, well, I'm not going to circle my problem numbers. Yes, you are. You are going to circle your problem numbers. This is the way I want you to do it from now until the end of your math education. I want you to circle all the problem numbers, and I want you to rectangle all the solutions. And that way somebody reading your homework can immediately see what's going on. They know this is the first problem, this is the second problem, this is the third problem, because they see those circled numbers. And they see your answer. They see that this is your answer for the first problem, this is your answer for the second problem, because it's rectangled. Immediately they know where to look to see what the problem is and what the solution is. This is the way you're going to do this from now, again, until the end of your math education. And this is not negotiable. This is a requirement for my course. So be sure and get that homework done, and I'll look forward to seeing you in the next class.